All right, guys, this video, we're going to move on to the second day of using the substitution method. And we're just going to add one step in. Now, from doing in class in the previous video, the first day substitution, remember you always ask yourself the question, is there a variable that's by itself? And all the examples we looked at, there was either an X or a Y by itself, and you would use that to substitute. Now, if you look at these 5, 6, 7, and 8, there's no variables by itself. There's the X and the Y are on the same side. So you can see how this is why we have the title of this, we have must isolate a variable first. Now, you have four options. You could get this X by itself, you could get this Y by itself, or this X or this Y. But you want to make this the easiest for yourself. So if for example, if you were to want to get this X by itself, you'd have to move over the Y, and then you would have to divide by this 3, and you would get fractions. What you always want to look for is you want to look for, out of the four variables, you want to look for if you have one X, which is really just like saying X, or one Y, because that's going to be one less step in getting that X or Y by itself. Now, if you look, I'm going to kind of erase what I did here. If you look at all four variables, here's the one Y. The first X, there's a 3 before it. In the second equation, there's 2X. And in the Y for the second equation, there's a negative before the Y. This is the one we want to get by itself. Now, all we have to do for this is just subtract 3X from both sides. And then this is going to become Y equals, when we subtract 3X on the right side, we have Y equals negative 3X plus 5. So that should look familiar. That's actually slope-intercept form. All right. Now we're at the same point that we were yesterday. We have a variable by itself. So if this Y is by itself, I'm going to underline this Y, underline the other Y. All right, I'll use a different color here. Now remember, we always want to put this in parentheses. Whatever is in parentheses, I want to substitute this into the other equation that's underlined, so to the other Y. So when we do this, we're going to work with the second equation. We're going to have 2X minus, and then this Y right here is replaced by everything that's in this parentheses, this negative 3X plus 5. Okay, and then don't forget this part, it equals 10. All right, that's the toughest part right there. Getting a variable by itself and then substituting that into the other equation. Once you do that, you should only have one letter. So I only have x's. So I'm going to solve for x first. This should be the easier part. So I'm going to distribute this negative. So I'm just going to bring down the 2x. So when I distribute the negative, negative times negative 3x is positive 3x. Negative times positive 5 is going to give me negative 5 equals 10. Okay, I can combine like terms. So 2x plus 3x is 5x. So 5x minus 5 equals 10. Right? This should be like a piece of cake right now. 2 steps. You're going to add 5 to each side. So we'll have 5x equals 10 plus 5 is 15. And then divide by 5, and we get x to equal 3. All right. Now we're almost there. I have the x value. I have to find the y value. Now, it's going to be the easiest to plug the x equals 3 back into this right here, what we have in parentheses, because you have y by itself. So I'm going to plug 3 right into that. So then when we do that, we're going to have, I'll put the work right here, y equals, we have negative 3. This x is replaced by the 3. So negative 3 plus, or negative 3 times negative 3 plus 5. All right, actually, this is positive 3. I made it negative, okay? You can see something like that, it's very easy to make. It's positive 3, I put a negative 3, but then I changed it. So negative 3 times 3 is negative 9. Negative 9 plus 5 is negative 4. So remember, to put it together is we list it as an ordered pair. the point of intersection is 3, -4. So don't forget the purpose of that. Well, what does 3, -4 mean? That means if we graph both of these lines, they're going to intersect right here at 3, -4. All right. Okay, let's look at 6. See if I can slide this over. Now for 6, again, we don't have a variable by itself. Make this a little bit easier. I'm just going to erase this. Okay, we don't have a variable completely by itself. Now, which one is the easiest to get by itself? Which x or which y? This should stand out. The first x should stand out. All right, because it's 1x. That's the easiest to get by itself. If you tried to get the other y or the x and the y for the second equation, you're going to wind up getting fractions. You don't ever want to get fractions with substitution. That would just make it ugly. So if we get this x by itself, the only thing we're going to do is subtract 3y from both sides. So this is just x equals -11 minus 3y. Now remember the process to kind of give me the visual cue. Whichever variable is by itself, I'm going to underline the x's for both equations. And then this, remember whatever I put in parentheses, this whole thing, this is what I'm going to substitute into this other x right here. All right, so I'm going to work with the second equation. So instead of doing 2 times x, I'm going to do 2 times. Now this x is the same thing as -11 minus 3y. So that's what I substitute. Then I just bring everything else down. The minus 5y equals 33. So the minus 5y equals 33. All right. And I would say that's the hardest part. If you can get to that part, you're good because you know how to solve a linear equation. All right. Now, how do I know I did this right? I only have one letter, right? I don't have x's and y's. In this case, I only have y's. So let's go ahead. Let's solve for this. Now, what should stand out are those parentheses. So we're going to distribute. So let's distribute 2. So 2 times -11 is -22. 2 times -3y is -6y. Then I just bring everything else down. The minus 5y equals 33. These are the like terms. And don't forget there's negatives before both. Just going to bring down the -22. So -6y minus 11y, or minus 5y, I gave the answer there, is -11y, right, equals 33. We just have 2 steps left. We're going to add 22 to both sides. So we just have -11y. 33 plus 22 is 55. And then divide both sides by -11. And 55 divided by -11 is -5. So that is the y value. Now remember, we're not done. I have to get both the x and the y. Now, whatever you kind of put in the box, that's where we're going to put the y value. All right, because this x is by itself. So we're going to plug y equals -5 right here. So to get x, we're going to have x equals -11 minus 3. And this y is replaced with -5. So we just solve for y. All right, then let's see, we would do -11. And then here, when you multiply, -3 times -5 is what? Positive 15. So we have plus 15. And then -11 plus 15 is 4. So we have x equals 4. So 99% done. To finish it off, let's put it together, write it as an ordered pair. So x comes first, so it's 4, -5. This is the point of intersection. This right there is the final answer. All right. So you can still see substitution, it takes a little bit of time. This we're adding one more step in because we do not have a variable by itself.